Hey everyone, welcome to part 3 in the third topic of our database class. In this video, I'm going to show you how to create primary keys and foreign keys using SQL, and I'll also do a live demonstration in SQL Server Management Studio. Let's get started. So let's learn next how we can create a primary key. Now, a primary key, as far as the structured query language is concerned, is considered a type of constraint. And like all constraints, we implement them in the structured query language using the constraint keyword. So this is exactly the same create table statement that we saw before, except in this one, we're going to add a primary key. So what do? Because I need a new line, here's our new line that creates the primary key. We're going to add a comma. Right? Remember previously, there was no comma after the employee name column definition, because that was previously our last line before the closing parenthesis. But now we're adding this constraint line, so that will be our new last line before the closing parenthesis, which means we need a comma here. Right? So the pattern then to create a primary key is use the keyword constraint, and then all constraints need to have a unique name. So we're going to give this one the name PK, meaning primary key, underscore, and then the name of the table, employee. Okay. This is, again, just a choice. I could name it whatever I want, but I like to give things meaningful names so that if I glance at this, I know that it is a primary key for the employee table just by the name of the constraint. And then I specify the pattern is constraint, name of the constraint, type of the constraint. In this case, it's a primary key constraint. And then inside parentheses, we specify the column or columns that we want to serve as the primary key for this table. So in this case, we're telling the database, hey there, database, I want you to create this employee table that will have an employee ID and an employee name column. And I want you to use employee ID as the primary key. Okay. Here we see another example, very similar, skill ID, skill name. And again, it's just about learning the pattern. So the keyword constraint, the name of the constraint, the type of the constraint, in this case, primary key, and the properties for that constraint. So let's see an example of this live. Always good to see live examples. All right, so I'm just going to drop this table. For now, I haven't reviewed the drop syntax yet, so I'm just using my point and click interface. So let's ensure that our table has a primary key when we create it this time. So constraint, name of the constraint, whatever we want to name it, right? And then the type of the constraint, primary key. And in this case, I need to specify the column or columns that I want to use as the primary key. So when we run this, oops, sorry, I've already got this. It's because I have an employee table already in here. Let's call that PK project since I'm now working on a project table. That makes a lot more sense, right? Project. I already have an employee table in this that has a PK employee primary key. So let's try running this again. There we go. Command completed successfully. Again, I will right click, refresh my list of tables, and you'll see we have our project table here. And if I take a look at the column, you can see our project ID column now has a little key symbol next to it, indicating that this is the primary key. So the primary key was set properly. If we wanted to go into the designer, right, this will look a little more familiar to us. You'll see that it's just as if we had created the table using the designer. Right? We have our little key symbol here indicating the primary key is set, project ID, project name, the two data types, and whether or not null values are allowed. Right? You'll see the primary key also exists under the keys option over here in your Object Explorer. PK project is the primary key for this table. Cool. So pretty easy to create tables with primary keys using the structured query language. It's all about the pattern, right? Constraint keyword, name of the constraint, type of constraint, in this case, primary key, and then its relevant properties. All right, let's continue building out our skills by next learning how to create a composite primary key, keeping in mind that a composite primary key is a primary key that consists of the combination of two or more columns. Okay. So to create something like that in SQL, we do exactly what we just did, what we've already learned. Constraint, the name of the constraint, in this case, a primary key. And if we want to create a primary key that consists of more than one column, all we need to do is specify the columns using a comma-separated list, as we see here. So this is saying we want to use employee ID, comma, skill ID. So the combination of employee ID and skill ID will be used as the basis or as the primary key for this table. So it's a composite primary key consisting of the combination of values from those two columns. Okay, so that's pretty easy. Let's see an example. Let's say that, I don't know, we want to create ourselves a little table that lets us keep track of who is on the project team. All right, I'll just modify this a little bit. Ooh, if I could spell employee ID. And we'll make that an integer as well. Why not? Just going to clean this up a little bit. So this is creating a new table. This one is going to be called project team. And you can see I've capitalized the name of the table. And in this case, we're going to create a primary key constraint that uses a composite primary key. So this one will be a combination of project ID and employee ID. All right. And when we run this, the command completed successfully. And I'll refresh my list of tables out here. And we'll take a look at our brand new project team table. And so if I look at the design view, you can see we just created this. Right? We've got project ID, employee ID, and you can see that they are both marked with a little key symbol, indicating that it is a composite primary key. Right? So that's the pattern for the composite key, just a comma-separated list of the columns that we want to serve as part of the key. Cool. Oh, not so bad. All right, let's continue building out our skills. What do we think is next? We haven't done foreign keys yet, so let's take a look at how to implement a foreign key using the structured query language. You'll note, by the way, just as a brief aside before we take a look at these foreign keys, that all we're doing is building our statement up, right? It starts off with our basic simple pattern, create table, the name of the table that we want to create, open parenthesis, close parenthesis. Everything in between there is a part of that create table statement. And then we first define our columns, right? So column name, column data type, null status, comma, column name, data type, null status, comma, column name, data type, null status, comma, and then we get to our constraints, right? So we first establish here a primary key, composite primary key in this case consisting of employee ID and skill ID. And then the new thing here is the foreign key. Again, a foreign key, like a primary key, is a constraint. So to create a foreign key, we begin with the constraint keyword, and then the name of the constraint, in this case, FK, meaning foreign key, skill. Okay, so this is a foreign key that's going to connect our current table to the skill table. Then the name of the constraint, or the type of constraint, which in this case is a foreign key, as opposed to a primary key like we saw previously. So the keywords are foreign key. And then we have a parenthesis, open and close parenthesis, and the name of the column in the current table that we want to be a part of this relationship. Okay. So this skill ID that we're referring to here is this one that we're defining right here. Okay, so we're saying take skill ID in this table, in our employee skill table, and link it to some other attribute in some other table. To do that, to establish the other end of that connection, we use the references keyword. This is like, where is it pointing to? And then we provide the name of the other table and then the other end of the connection. So we're saying connect to the skill ID column in the skill table. So I want to take this skill ID here, this one here, which remember is what we're referencing here. And I want to connect that to this skill ID in the skill table. Naturally, this means that this table must already exist. Right? I'm telling it to connect my new table, so I'm proposing here to create a new table called employee skill. And I want it to connect to the skill table by linking the skill ID in this table, my new table, to skill ID in the skill table. So this has to exist already in order for this to work. Otherwise, I'll get an error. So the order in which you create your tables matters. Right? The skill table in this case must exist before I can create the employee skill table, because I'm establishing a foreign key in the employee skill table that will connect to this other one. Now let's see an example. A live example here over in SQL Server Management Studio. So once again, I'll just right-click and delete our new project team table. Okay. Now let's say that we want to connect our employee ID here to employee ID over here in our employee table. We can do that with our newfound knowledge. Again, constraint, and then the name of the constraint. In this case, I'm going to connect my, I'm going to call this connect project team to the employee table. A long name, but at least it tells me what it is. And then the type of the constraint, foreign key. And again, I want to use, in this case, the ID in this table. Running out of room here. And I'm going to continue this on another line. And then we have to tell it what is the other end of that connection. So it's going to point to the employee table. And specifically, I'm interested in connecting to the employee ID attribute within the employee table. Right? So this is saying connect employee ID here, which is this one, to this employee ID over here in our employee table. Right? So if we go ahead and run this now, you'll see we get our command executed successfully. And if we were to take a look, I'll refresh my list of tables again. Take a look at our project team table that we just created. Look at its keys. We'll see that we have our primary key and we have a foreign key that we created here. And if I were to pull up our database diagram, let's see if we can visualize this out here. We'll add our new table. Right, we've got project and project team. So here are our two new tables that we've been playing with recently. And you'll see that by creating that foreign key relationship, make a little real estate here. Our project team table is now connected to the employee table in our little diagram. Right? So you see we've got this relationship line here because we told it using our SQL command that we wanted it to connect employee ID here to employee ID there. Okay. So you can see it visually in this diagram. What we've done here with our little SQL command has created this table for us, defined its columns and their data types and their null statuses, set the primary key, right, and also established a lovely foreign key relationship. So if we wanted to further wire this thing up, let's close this down here momentarily. And let's say that we add the final connection, which would be over to that project table. Being lazy, I'm just going to copy and paste this. I don't have to type it all out. This will be connecting the project team table to the project table. And in this case, we're going to connect based on matching values of project ID. This connects to the project table. Right? And I get rid of the comma since it's my last line. So let me once again delete this, and we'll run it one last time. And here we go. Hooray. So now if we took a look at our database diagram and we added those two new tables to the diagram, we would see visually that our database is looking a little more complicated at this point, right? We've got our project team table here that connects to the employee table and to the project table. So we've got this new relationship that we established, and we could then use this new to our database structure that we added today as a basis for keeping track of, say, which employees are working on which projects. Also note that the data types for the two attributes that are serving as the two ends of the relationship, the data types must match. Okay, so in this case, if skill ID in the current table is an integer, then this skill ID over here in the skill table must also be an integer. Right? And this makes sense because, as we know by now, we establish these relationships in the relational database model by using matching pairs of values. Okay? So we need to link an integer to an integer. It wouldn't make sense to try to link an integer to a date or an integer to some text, right? Those values will never match. They will never be seen by the database as equivalent. So in order to connect the rows in one table to those in the other, the attributes that we're using need to have the same data type. In this case, skill ID should be an integer in both tables, in the skill table and here in our new table that we're creating, the employee skill table. We have one more thing to learn about these foreign keys, these relationships between tables in the structured query language. So the last thing that we need to learn is about this idea of cascading updates and cascading deletes. Now, first, I want to point out the structured query language differences, and then we'll take a look over at SQL Server and see a practical example of how this works so that we can fully understand what's going on when we use a cascading update or delete. Now, you'll note here in this example that we've modified our foreign key constraint a little bit and added this additional piece of information at the end of that constraint. This one says on delete cascade. Down here below, we see on update cascade. Okay. So this is a new thing. And in order to understand what's going on here, we need to know what the notion of these cascading updates or deletes means. What does that mean? So the basic idea here is just conceptually, if we have a statement like this that says on update cascade, what that means is that if we're going to change or update a value in our table, let's say that we update the employee ID here in the employee table from 7 to 10, if we are using a cascading update, then what will happen is that the database will automatically follow this relationship, this foreign key relationship, from the employee table over to the other end of the relationship, which in this case is our new employee skill table. And it will look at values of the employee ID in the table at the other end of the relationship, and will make the same updates there. So if I changed employee ID in the employee table from 7 to 10, the database would automatically go and look in the employee skill table at the other end of the relationship and would try to find values of employee ID where it's 7. And if it finds any of those, it will automatically update them to the new value of 10, thus maintaining the connection between the rows in the related tables. Okay? So I change employee ID here in the employee table. That change will cascade across that relationship line over to our employee skill table, and matching values of employee ID in the employee skill table will also be updated to reflect the change in the employee table. This way, we're not breaking any connections between the rows in these tables. A similar concept applies to the notion of a cascading delete. So the idea here is if we implement a cascading delete, and say we're looking over here at the skill table and we decide to delete the record in that table for skill ID number 3. Okay, so we delete row number 3 out of the skill table. If a cascading delete is established on this relationship, then what will happen is the database will follow that relationship line over to our employee skill table. Right? That's the other end of that relationship. And it's going to look through the rows, and it will try to find any rows that have a skill ID, in this case, whose value is 3. And if it finds any of those rows, it will automatically delete them, because we would have already deleted the related row at the other end of the relationship. So if I'm looking in the skill table and I delete the row that has skill ID number 3, and I stop there, then I will probably have one or more rows in this employee skill table where the skill ID value is still equal to 3. And that would no longer be connected to any row in the skill table because we would have deleted the row at the other end of the relationship. So this is all hard to understand when you look at it in the form of text or try to imagine it in your minds. And for that reason, I think it's an excellent opportunity for us to just see a live demonstration of how this works. And thereby, we should be able to get a pretty intuitive understanding of what's going on with these cascade updates and deletes. So currently, I'll show you this by right-clicking on this relationship line. If I right-click on the relationship and select Properties, you'll see here in this Properties window that pops up that we have something labeled as a delete rule and an update rule. And this is where we can set the behavior that we would like to happen for this relationship using the SQL Server Management Studio point and click interface. So if I wanted to establish, say, a cascading update, I would change no action to cascade. Same thing if I wanted to do it with a delete. Right? If I wanted a cascading delete, I would change no action to cascade. And if I were to do that, then if values in one of the connected tables were updated, that change would cascade or travel along the relationship line, right? So if I were, for example, to change the value of project ID here from, 5 to 6, then what the database is going to do is it's going to follow this relationship line and look over here in the project team table for any project IDs that are currently 5. And if it finds any, it will update those to 6 so that the connection between this table and this table we're not going to break any relationships by making the change in one place. That change will automatically be applied to the other end of the relationship as well. So that's a cascading update. And of course, a delete is a similar concept. Right? If we were to delete a specific project ID or a row with a specific project ID out of this table, say we delete project number 77, the database will automatically look over here at the other end of this relationship for any records in the table where the project ID is equal to 77. And with a cascading delete in place, if it finds any rows with a project ID of 77, those rows will automatically be deleted, therefore preventing us from leaving any stranded or orphan rows in the project table or in the project team table that point to a project that no longer exists. Right? So if I delete project number 77 here, it doesn't make any sense for me to have any projects over here that say that they're project 77, because as far as the database is concerned, project 77 doesn't exist anymore. So a cascading delete will take care of that for us. Now let's see some examples of these, some practical examples. So I made those changes earlier. I'll save that to our tables here. And then we'll add some data and see if we can just see a live demonstration of this. So we'll take a look at our project table. Refresh our list of tables so that everything is there. There we go. So we'll just go and add some data here in our project table. Adding data. And it's a very simple table design, just 2 attributes, so it should be pretty easy. We'll create, say, project number 1. I don't know what to call this. I'll call it project 1, just for the sake of having something to call it. And maybe project number 2. Call this project 2. All right, so easy enough. Just creating a couple of rows of data out there. And then we'll create, briefly, just take a look at our employee table so we can see what we have out here for employees. So you can see we have employees. They're numbered 1 through 12. Okay, so that's our valid set of employees. And if we want to establish a connection between employees and projects so that we can keep track of which employees work on which projects, we'll have to add some records to this project team table. So let's just go out there and add a couple of rows. And we'll say project 1 has employee number 12 and employee number 3 and employee number 7 working on it. And project number 2 has employee 2 and employee 1 and employee 12. Yeah. So we now have connections established between our projects and the employees who are working on those projects. And with this information, the database, of course, could answer some questions for us. If we were to say, hey, database, what projects is employee number 12 working on? The database could look through this project team table and say, well, okay, here's employee number 12. So we know that employee is currently working on project 1. And then we look through the rest of the rows. Here's another one. So employee number 12, the answer to our original question is that employee is working on both projects 1 and 2. Similarly, we could ask the database, like, hey, database, which employees are working on project number 1? And then the database would say, all right, I'm going to look out here. Here's a project 1. Here's a project 1. Here's a project 1. So I know that the answer to the question is employees 12, 3, and 7 are the employees who are currently working on project number 1. So we can see here that our project team table allows us to establish these connections between projects and employees, right? Now, keeping in mind that we have established on this relationship some cascading updates and deletes, right? We see those are cascading updates and deletes in place. Let's see what happens when we try to delete something. So I'll load up our data for the project table again. And we'll just, let's say that we decide to delete project number 1. So remember, I'm just in the project table, right? And I'm going to delete project number 1. It'll say, hey, you sure you want to do this? And I'll say, yes, database, I'm sure. So project number 1 no longer exists in our project table. That's the only change that we just made, was to delete that one row. However, if we now take a look at our project team table, we'll see that no records exist anymore with a project ID value of 1. Right? That delete that we made over in the project table cascaded here to the project team table, and any matching records where the project ID was equal to 1 were automatically deleted here. Okay, so we didn't leave any orphan records out there that were pointing to a project that no longer exists. They were automatically deleted. So you can see a very visual example there of a cascading delete. And of course, a cascading update is a very similar concept. So if I take a look at our project table again, and I just go in there to edit some of the data, let's say that we change project ID 2 to, I don't know, project ID 1002. Right? So we're just updating that value of the project ID. So that change is made. Why is this grumpy with me? Oh, I've got to commit it. That's why. All right. So, and just to reiterate, so we made that change. And if I just pull the data, we just have this one record in there, project number 1002. We just made that change in that one single place. But if we look now at the connected table, the project team table, remember it's connected through this relationship line. So we look in project team and we take a look at the data out there. You'll see that the project ID for the projects that previously had a value of 2 have now all automatically been updated to match the change that we made in the other table. So as you can imagine, this helps to preserve the quality and accuracy of the data in the database. And if I make a change in one place, it's going to automatically cascade to other places where if we did not make the update in those other places, we would suddenly have a lot of broken relationships in the database. So these are cascading updates and deletes, and very easy to implement. I want to point out that there are some other options available for this type of behavior. So for example, currently we're using cascade as our delete and update rules, but you can see there are some other options out here as well. Do nothing, right? And if I do nothing, then the change will not follow the relationship line and will not be applied to matching records in the other table. So this will yield broken relationships. Other options are set null. So for example, if I delete a project, then all of the matching projects in the connected table will have their project IDs set to null, assuming that null values are allowed for those project IDs. And you can see we also have a set default option. So if we've established a default value for the attribute at the other end of the relationship, and we make a change, the database will update the other end of the relationship and set the value to whatever its default is. But generally, cascades are quite common because they, as we saw with these examples, allow us to preserve the quality of the data in the database by ensuring that those connections remain connected. Cool. All right, so what I'd like to do now is just demonstrate that you can do this in SQL quite easily. You don't have to just point and click your way here. So what I will do is just go ahead and delete this relationship here. And we'll get rid of that one, and we'll get rid of this one. And then we'll get rid of our project team table. I'm going to delete this table as well. And we'll ensure that all of our changes are committed or saved to the database. And then we'll return to our SQL statement from last time. All right, so this was our create table statement from last time, which would create a table named project team. And remember, it points to our employees database. In this case, we want the statement to be sent to the employees database, so I ensure that that's selected on the dropdown. Now, the only difference between what we saw here from last time and what we just learned about these cascading updates and deletes is that we need to add the instructions to do a cascading update or delete. Okay, so if I want to do a cascading update, I would say on update cascade, and I of course can do that for both of these foreign keys if I choose to. And that would establish a cascading update. But if I wanted to do a cascading delete as well, I would need to add that instruction. So I would say on update cascade, on update delete. Okay. Add these things in here. And that's all there is to it. So in this case, we would have our updating or our updates and cascading updates and deletes established. Let's focus for now just on one of these relationships so that we can see this work. Right, so we'll do a cascading update on the relationship between, actually, let's do it for the one that we saw previously through point and click. So we'll do it down here. So we do on update cascade, and this will be connecting the project ID in the project table to the project ID in our soon to be created project team table. So we go ahead and run that, and you'll see command completed successfully. And if I refresh my list of tables, got our project team table newly created over here. We take a look at our database diagram. We should now be able to add that table back since it once again exists. So we add that here to the diagram, and we'll see that the relationships are in place just as before. This one's kind of hard to see all. Get these out of them. So you've got this kind of weird relationship line that I don't know why it's drawing it like that. But anyway, project team is connected to employee and project team is connected to project, even though this relationship line is weird. Maybe if I move that up, it'll clean it up a bit. Anyway, and if we took a look at this relationship now, just visually, we would see that we have no action specified for the delete, and we have a cascading update specified here. So you can see that by writing our SQL statement, we're able to achieve the same result, in this case by adding on update cascade. And that will allow us to do cascading updates when changes are made to project IDs.